So Pythagorean theorem applications. Okay, so here's the first one. We're going to find the measure of these two pyramids. All right, we got the measure of Khafre's pyramid, and I want to find what is the measure of L in the first one. L is the slant height of this pyramid. How do I find the measure of L? So we want to use the Pythagorean theorem somehow. Pythagorean theorem applies to what kind of triangles? Right triangles. Where is the right triangle here? Can we see the right triangle? And hopefully we can. So you see the right triangle. This right triangle should be from the top of the pyramid, straight down. Hopefully that 90-degree angle helped you out. Straight across, and up, back again. So there's my first right triangle there. So let's get this one, and let's fill in. What's my A? Yeah, we got 446 here. What's my B? 352. Here's my right angle, and C is the unknown. Alright, so if we're using the Pythagorean theorem, so A squared plus B squared equals C squared. I'm solving for C, so I'm going to solve this for C right off the bat. So C is equal to the square root of A squared plus B squared. And I'm going to plug in my A, which is 446 squared, plus my B, which is 352 squared. And I'm going to find the square root of that. So what is C equal to, or what is this slant height equal to here after I take, so again, you can put this in your calculator all one shot. The square root of, parentheses, 446, close parentheses squared, all that good stuff. And do I have an answer for the square root of 446 squared plus 352 squared? Got to take the square root of that. So let's say about 568. And we're going to say feet because this actually told me to round to the nearest foot in the previous directions. So about 568 feet. So I'm going to find, so number 2, what is the measure of Medicire's pyramid? So we have another right triangle here. My A is this leg here. So A is equal to 203 feet. My B is this leg here, which is equal to 172 feet, and my C is the unknown here in blue. That's my C, or my leg, which is my hypotenuse, which is unknown. Alright, so I'm going to use the same formula as the first one, so I'm going to steal that formula there. So C equals the square root of A squared plus B squared. C equals, plug in, so 203 squared plus 172 squared, and if I plug this into my calculator, I get about 266 feet. Length of the diagonal here. All right, so we're going to apply the Pythagorean theorem to this 3D shape. So I'm looking for the diagonal. All right, so the diagonal is that line going from the corner of the box to the opposite corner in a different plane, right? So that's the diagonal I'm looking for. In order to get this diagonal, I'm going to actually use the Pythagorean theorem twice. I'm going to look at my base. Right, so my base is here, my bottom rectangle. And in that bottom rectangle, it forms a right triangle. So where's that right triangle? Between, yep.
So it's going to be from the 12 inches and the 5 inches, and then down from the right one.
Okay, so it should be from here to here. So I have one diagonal on the bottom of the box from this corner to this corner, and the other diagonal that I'm looking for uses this diagonal as C, but it uses this as one leg, and it uses the diagonal from the bottom box as its second leg. So the diagonal from the bottom, so from that bottom rectangle, which has a length of 12 and a width of 5, has a diagonal from here to here. Let's solve that diagonal. That diagonal is actually the B term, or one of the legs of the final diagonal I need to find. So I have A, this diagonal will be B, and this diagonal here would be C. But I need to find this B. This B is the diagonal of the bottom square. So we know that A is 5, B is 12, C is my unknown, so I'm solving for C. So again, if I use A squared plus B squared is equal to C squared, solve for C by taking the square root of both sides. So C equals the square root of A squared plus B squared. So C equals the square root of 12 squared plus 5 squared, and C is equal to 13 inches. Okay, so that's just this piece here. So now I know what this one is. This in here is 13 inches. So now I'm going to use this 13 inches as one of my legs of this red triangle. I'm going to use this 6 inches as one of the legs of this red triangle. And I'm going to solve for that missing diagonal from one corner of the box to the upper corner of that box. So again, I'm going to use this formula here. So C equals the square root of A squared plus B squared. C is equal to 13 squared plus 6 squared. And after all said and done, C is equal to the square root of 205, which is about, if I round this, 14.3, I believe. 14.3 inches if I round to the nearest tenth. Diagonal of the following cylinder. Alright, so here's my diagonal. I'm going to highlight in red, which is highlighted in black. So I'm at that diagonal. I'm looking for that length. I'm hoping to utilize the Pythagorean theorem here. So if I want to utilize the Pythagorean theorem, I want to try to create a right triangle somewhere. Yep.
So that's going to
be.
be.
Okay, so I could use this, which will be 8, which is the opposite side.
The diameter is going to be 6 because it's twice 3.
Good, and I'm going to use the diameter, which is going to be 6. So from here to here is 6 because the radius is 3. So 3 and 3 is 6. This side's 8. This side's 8. So I have a right triangle. So if I steal all this, just bring it over out of the picture. I have a right triangle. That's 6, 8. Can we do that without the math? 6, 8, 10. Excellent. And that comes from a 3, 4, 5 triangle. So 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. But we're going to go through the motions on this one just to show the work. So I'm sure most teachers would like to see the work. So I have a side of 8. So I have A is equal to 8. B is equal to 6. And A and B are interchangeable. It doesn't matter. The one that's most important is that C. So C is the unknown at the moment. So again, so C equals, stealing the formula from the previous problem, A squared plus B squared. So C is equal to 8 squared plus 6 squared, which is going to be square root of 100 or 10